Corporate finance practice problem using Onenote. Calculating bond value where the bond has semi-annual payments. Get ready, it's time to take your chance with corporate finance. Here we are in Onenote. If you have access to Onenote and would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the practice problems, then down in the 1031 bond value semi-annual payments tab. Also note that when using Onenote, you might want to look at the immersive reader tool. Many of our presentations are also down here in the text area with the same number and name, having their transcripts that can be translated into multiple different languages and either listened to or read in those languages, thereby being a good complement to the practice problems up top. Closing up this tab, we're going to have our information up at the top. We're going to then calculate that down below in the blue area. We have the calculation of the bond value as we've seen in the past, but different twist, different complication, that being not annual payments, but semi-annual payments. That's the new thing here. So we have the issue on the bond face amount, $1,500. Life is going to be then 12 years. The rate is going to be 12%. These are the things that we're getting from the bond, as well as the semi-annualness of the payment. The thing that would not be on the bond, market rate down here at the 14%, that would be driven by the market. So what we want to do then is figure out the value of the bond, noting that the market rate is higher than the rate on the bond. Therefore, if we're sitting here thinking we're going to sell the bond from the position of the seller, we're at a disadvantage, you would think, because the people buying the bond could then invest elsewhere and they could say, hey, look, I can get another bond that's really similar to your bond and I can get 14% and yours only gives me 12%. And therefore, we're thinking we're going to have to issue this bond at a discount. So we expect then the answer to be a discount. The new thing here, because they're not annual payments but semi-annual, means that when we do our calculation, the life here is going to be translated into the periods. This is what we're going to assume in years, but periods is going to have to be multiplied times 2 to get the number of periods, which are 6-month periods, half-year periods. And then the rate here, 12%, if we're talking about the calculation of the rate for the payments, once again, that's a yearly rate. We're going to have to think about it in terms of a 6-month rate. If we're paying interest semi-annual, market rate, same thing. That's typically going to be a yearly rate. We'll have to break it down to whatever period we need, 6-month period, most likely in our calculations here. Note that whenever you think about interest, when someone gives you an interest rate, typically the assumption, the convention is that it's going to be a yearly rate. And then if you need to break it down to some other rate for your calculations, you then do so. That's a convention that is useful due to the fact that if we start breaking our rates down to match up to periods that are smaller, semi-annual, monthly, for example, quarterly, we get to very small percents or have the possibility of doing so. Those are more difficult to basically talk about, those smaller rates, although those are not difficult for a computer to be dealing with. So just keep that in mind when you see the rate. You're typically thinking yearly rate. If you're calculating something other than a year, semi-annual in this case, 6-month periods, you have to make sure that you're taking that into consideration. So we have the same kind of starting point as if they were annual, in that we need to still value this in 2 ways, meaning 2 types of things we need to value. One is the annuity that's taking place, which is the 1,500 times the amount on the bond, 12%, but then divided by 2. And that's going to go for not 12 periods, but 24 periods, because they're 6-month periods. And we'll have to do the present value of 1, which is going to be the face amount of the bond. So we'll start here with the annuity. We could see it in terms of our calculation formula. That would be P times 1 minus 1 plus R to the negative N over R. P then is going to be that 1,500 times 12%, but then divided by 2 because semi-annual. And then we'll multiply that times 1 minus 1 plus R. R, the market rate, 14%, but then divided by 2 because it's semi-annual, to the negative N, the number of periods, which would be 12, but that's years. We're assuming years here. Multiplied times 2 because we're talking 6-month periods, would be 24 periods of 6 months, divided by R, also once again the market rate at 14%, but need to divide it by 2 because semi-annual. So let's go ahead and break this out. We'll then say that let's put this into our table. We're first going to calculate P in the outer column. And that's going to be the 1500 times 0.12. That would be 180 if it was for a year, divided by 2, and then we get the 90. That's how I would calculate it typically if I was doing it with a calculator, but it's also useful to note that you could take the rate and convert it to the rate per 6-month time period first. So that would be 0.12 divided by 2, or 0.06, 6% per 6-month time period. That's the rate per period, times the 1500. That's useful to know because that's the method or the format that you might have when using kind of functions in Excel. You're going to take the rate and like convert it to the monthly rate, or in this case, the semi-annual rate. Then we'll calculate the numerator, pulling that into the inside. We've got 1, and then 1 plus r to the negative n. 1 plus r is that 14%. Now we're talking the market rate, but divided by 2 because semi-annual. So that's the rate per 6-month time period. 1 plus 7% is 107%, or 100% plus 7%, or 1 plus 0.07. Then we take that to the power of the number of periods, which would be 12 if yearly annual payments, but it's semi-annual, so 12 divided by 2, or times 2, is 24. So taking 107 to the power of negative 24 is that 0.1971466. Let's go ahead and calculate that. And to do that, because I want to just emphasize that you need the special calculator, or some kind of calculator that can take you to the power of negative 24. In Windows here, I'm going to go to the scientific calculator to do that, and do this all scientific-like. So it would be 1 plus 0.07. That's the 1.07, or 107% to the power of x to the y, 24. Then I'm going to put the negative sign here, so it's caret negative 24, and then equals. And there's the 0.1971466 about. Obviously, rounding is in effect here. Going to convert back to the standard calculator because I don't like being scientific all the time. It's just, it's back to the normal calculator. Got to be normal from time to time for the most part. It's going to be 1 minus the 0.1974166, and that's going to be the 0.8028534 about. That's going to be then the num. And now we're going to pick up the denominator. That's going to be the 7% again, which is the 14% market rate divided by 2. Taking the num divided by the denom, 0.8028534 divided by 0.07 is going to then give us the 11.469, and so on and so forth. And we can then take that and multiply it times the 90, and we get the about 1032.24 about. So that's going to be the value of the annuity. Then we'd need to do the present value of 1 for that 1,500, add them together. But before we do, let's do this one a few more times using a few different methods. First, let's break this down into not 12, but 24 single periods present value of 1 type of calculations to see what that would look like. Remember that you can break down an annuity basically in this format. So we're going to say then the period 1 period 1 is going to be that 90 being the 1,500 times the 12% divided by 2. If we present value that 1 period out, which we will not do the calculation for here, we're going to imagine we do it in Excel. If you want to see this in Excel, you can do so, but in Excel, fairly easy calculation to make. That would be 84. If we continue this on down, the second payment, also 90 because it's an annuity, and that means all the payments are the same. So if we bring that back 2 periods, we get the 79, and that's going to be the 79 plus the 84 is the 163. If we do this again, third payment 90, bringing that back 3 periods, present value of 173, 73 plus the 163 equals the 236, and so on and so forth, all the way down till we get to 24 periods. Remember that these periods do not represent years, they represent periods, in this case 6-month periods or half years. And that would give us to that 1032 again right there. And we can also do this one more time, and we can put the 1,500 face amount, bringing that back also 24 periods, because that would be given at the end of the time period. And that would be at the 296 plus the 1032. That would then be the answer. 1028 would be basically the value. Note that that value is less than the 1,500, which is what we would expect given the fact that the market rate is higher than the rate on the bond, and therefore these bonds would need to be issued at a discount. So we did this kind of kind of magically with what we can imagine what would happen in Excel. We'll do these calculations again. But first, let's look at this 1032 again. We can look at that with regards to an Excel function. The Excel function is a little bit more complex because you've got to remember as you do this, when you put this into the function, that you're taking into consideration the matching of the rate and the number of periods and lining those up properly. So we got the present value, and then we have the rate. The rate would then be the market rate, the 14% divided by 2. So note the formula would be picking up that cell, 14% divided by 2, and that's going to be a hard-coded number, and of course that would be the 7% now in Excel. Comma, then we're going to say the number of periods would be 12 times 2. So notice I'm going to reference the cell up here, times 2, and then comma, the payment is going to be the 1,500 times the rate on the bond, 12%, but that would be for a year divided by 2. So we'd pick up that 1,005 times the 12% divided by 2. That then gives us, once again, the 1,032.24. So it's a little bit more complex. Once you do that a few times, you get used to putting this into a function, and it becomes somewhat clear, but making sure that you get the proper amount of periods and the proper percent that lines up to the period is something that needs to be worked on, and making sure that you're getting that right. Also, same thing, same concept with the tables. It's useful to look at the tables when you have something like this as well, but remember that the tables become less useful as you start to have like semi-annual payments and so on, because the number of periods is going to get much longer, and the tables can only go down so far and still be relevant. So here we have, for example, 24 periods and 12 or not 14 divided by 2 or 7. So we're looking 7 and 24. Now, when we look at the periods down here, we have the percentages and then the number of periods. It's oftentimes people start to think of these percentages as yearly percents. They're not. They're percents that line up to whatever period we have over here. So over here, we're going to assume these periods are 6-month periods, and we got to make sure that the rate that we are using lines up to the period that we are using. And so we're talking 7% per 6 months and 24 6-month periods down here at the 24. That's going to be the 11.469. So 11.469 times the 90 gives us the 1,032.21. That's going to be close to the 1,032.24 we got before, a little bit different due to the tables rounding to the 4 digits, or 4 digits down there. So now let's do the present value of the 1,500, and we're going to bring that all the way back to the 24 periods. So we're going to use the present value formula. Present value equals future value. I can say over 1 plus r to the n. The future value is going to be that 1,500. 1 plus r. R is going to be the market rate, 14% divided by 2, or 7%, to the number of periods, which would be 12 if annual, because those are years, but then times 2 to get to 24. Let's put that into our table and check it out. We got the 1,500. That's the num, or numerator. We got the 1 plus r to the n, not negative, to the n, denominator. 1. R, 7%, that's that 14% divided by 2, 7%, 100% plus 7%, or 1 plus 0.07 gives us 1.07, or 107%, taking that to the number of periods, to n, which would be 12 if annual, but now 24 because semi-annual. 107% to the power of 24 gives us 5.072367, taking the num, the 1,500, divided by the denom, the 5.07267, I think I missed a 3, but you see the number right there. It's right there. That will give us the 295.72. That's going to be the present value of that 1,500 payment at the end of the maturity of the bond, adding that 9,295.72 to the value of the annuity at the 1,032.24 gives us the value of the bond again at 1,327.96. So that's what we would consider the price to be, the fair price at this point in time, given the market rate of that 14 annual percent. And we can see that it is lower than the 1,500 due to the fact that the interest rate that's on the market, 14%, is higher than the interest rate on the bond. Therefore, the bond would need to be issued at a discount if they want to sell it. Let's do this 295.72 a couple more times here. We could do that with Excel, making sure that we're picking up the proper rates. So we got present value. The rate would be that 14% divided by 2. So we had 14% divided by 2. That would give us the 7, comma. Number of periods would be that 12 times 2, which would give us the 24, comma, because it's not an annuity, would be the future value, which would be that 1,500. That gives us the 295.72 again. And then we can also get to that number using the tables, being careful that we have one, the proper table, that being the present value of 1, not an annuity, and 2, the proper rate and period, which is no longer years and yearly rate, but it's now periods of 6-month periods and 6-month rate. Periods then being 24, 12 times 2, rate being the market rate, 14 divided by 2, or 7. 7% market rate per period, per 6-month period, for 24 6-month periods. So 724, 724 is going to be that 0.1971. So the 1,500 times the 0.1971 is going to give us that 295.65. And that 295.65 is slightly different than the 295.72 that we got before because the rounding, the tables round to the 4 digits.